This is Let It Snow math count. While snowstorms in Middletown, USA routinely leave up to 5 feet of snow on the ground, the first winter snowstorm deposits, on average, 18.7 inches of snow. So it routinely, I'm going to use a highlighter for this. It routinely leaves up 5 feet of snow on the ground, and the first winter snowstorm deposits, on average, 18.7 inches of snow. According to the Public Works Department, the snow removal rate is directly proportional. So the snow removal rate is directly proportional to the number of inches of fallen snow. For the town's fleet of snowplows to clear all the roads after a storm leaving 10 inches. So after a storm leaving 10 inches of fresh snow on the ground, it takes 25 minutes. It takes 1 hour to clear the town's roads after 24 inches of freshly fallen snow. If the rate of the snow removal remains constant, so that's a good word right there, constant, so it doesn't change, how many minutes will it take to clear all the snows in town after the first winter snowstorm, assuming it deposits 18.7 inches of snow? And we have to express it to the nearest minute. All right. So this is definitely a ratios and proportional word problem right here. And first it's giving us the ratio, then it's asking us to fill in the ratio for 18.7. So first, let's express the ratios. So over here, I'm going to write inches of snow to minutes. Minutes needed to clean up. So it first says that that a storm leaving 10 inches of fresh snow, 10 inches, needs 25 minutes to clear out. And it takes 1 hour, and that's really 60 minutes, to clear up the town road's 24 inches of freshly fallen snow. And as you can see, if I do it this way, it's very, very clear what my ratios are and what I can do to solve. So if there is 18.7 inches of snow, what is this number over here? How much minutes does it take? Well, really, the first thing we have to do here is find if there is only 1 inches of snow, how much minutes will it take? Matt, call them on So if we were to do that, let's see over here. Well, let's use the 10. So if we divide each side by 10, the left side would be 1, and the right side would be 25 divided by 10, which is equal to 2.5. And let's check our answer right here. So 24 times 2.5 is equal to 48 plus 12, which is equal to 60. So yes, that works. And over here would be 2.5. Now we're just going to multiply each side by 18.7 so we can get the number of minutes it will take to clear up 18.7 inches of snow. So all you have to do right here is to get this box, 18.7 times 2.5. And after that, you'll get 46.75. So there we go. We did it. We answered the first problem. Or did we? We especially underlined that it said to express your answer to the nearest minute. So instead, the answer isn't 46.75. It's 46.75 rounded to the nearest minute, which will round up to 47. So it would take approximately 47 minutes to clear up 18.7 inches of snow. Now let's do the second problem. All right, let me first, clear this up. Okay. After each snowstorm in big city USA, plows remove snow from 762 lane miles of road, which is equivalent to about 48 million square feet. The snowfall total was 34.2 inches in Big City, USA last winter. Suppose every snowfall evenly blanketed all road surfaces. How many cubic feet of snow were plowed last winter in Big City, USA? Okay. So let's reread the problem over here. What did it say? So it says that it removes snow from 762 lane miles of road. Okay. Yep. So it removes snow from 762 lane miles of road. Okay, which is equivalent to about this much square feet. The snowfall total. Okay, so snowfall is 34.2 inches. Snowfall was 34.2 inches in Big City, USA last winter. Suppose every snowfall evenly blanketed all road surfaces. So that's important. It's just like how it's constant over here. It says it's evenly blanketed all road surfaces, which makes the problem easier for us to do. So how many cubic feet of snow were plowed last winter in Big City, USA? So over here, it said that it was evenly blanketing all road surfaces. So basically, if this was a road and this was a snow surface, over here it was 34.2 inches, and it's everywhere, 34.2 inches. So what we can do right here is just times 34.2 with, and it says cubic feet of snow. So times, and I would do 4.8, and with the scientific notation 1, 2, 3, 4, 5, 6, 7 to the times 10 to the 7th power, and you'll get this number right here, and this is your final answer. Now suppose that 1 cubic foot of snow weighs about 15 pounds. Based on this information and the last problem, approximately how many tons of snow were plowed in Big City, USA last winter? Okay, so we know that, should add these zeros over here. Okay, so we know that there were this many cubic feet of snow plowed last winter in Big City, USA. And every of these cubic feet weighs about 15 pounds. So we're going to have to do, and then we're trying to find how many tons of snow were plowed in Big City, USA last winter. All right, so we're going to do 1,641,600,000 times 15, and then we're going to get a final answer. Then you'll get 24,624,000,000 and then 6 zeros. So there we go. That's what's our answer, right? That's how many tons of snow were plowed in Big City, USA last winter. Actually, that's not the answer because of the unit. Over here it says tons, while over here it says pounds. Those aren't the same unit, so we have to convert them and answer with tons. This is pounds only. So if you remember, when turning the units, when shifting the units, we need to know that 1 ton is equal to 2,000 pounds. So all we have to do over here is divide 24,624,000,000 by 2,000, which is equal to 12,312,000 tons. So how many tons were plowed in Big City, USA last winter? 12,312,000 tons were plowed. All right, moving on to the next problem. All right, I'm just going to put this away right here. Shift that. Okay. All right. Now we're going to do the next problem. Twin brothers Kenny and Aziza live in small town USA where it snows an average of 55 days each winter. They take turns shoveling the walkway after each snowfall. Kenny can shovel the walkway in 22 minutes, while it takes Aziza only 14 minutes to shovel the same walkway. How many minutes will it take to shovel the walkway if they work together? Express your answer as a decimal to the nearest